smash some avocado, squeeze some lemon, or make some guacamole, because today we are talking about moles, a fundamental unit in A-level chemistry. Let's dive straight in. What is a mole? A mole is simply a massive number of particles. You can have a mole of anything. You can have a mole of laptops, sunglasses, and of course atoms. And that's what we care about. A mole of things contains 6.02 times 10 to the 23 things. The value of the mole is set so that a mole of carbon-12 atoms weighs 12 grams. This is important because the mass of one carbon-12 atom is 12 AMU. So the mole converts between AMU and grams. So 1 gram equals 1 mole times 1 AMU. If you're not sure what AMU is, make sure you check out the episode on relative masses in this revision series. So why do we bother doing all of this crap? So we use moles for convenience. Atoms are like super tiny, so it's very difficult to measure a single atom. By using the mole, we can do calculations about the amount of stuff we have in any reaction. So the number of particles we have is the number of moles times Avogadro's constant, and that was that 6.02 times 10 to the 23 number. 6.02 times 10 to the 23. Let's go over concentrations. A mole isn't very useful when dealing with liquids or solutions. It's easier to deal with volumes of fluids. So we need a value that will let us know how much of a solid is dissolved in a solution simply from its volumes. If we know the concentration of a solution, we can calculate the number of moles in any sample volume of the solution. Ooh, but how? I'm glad you asked. Concentration is defined as moles per unit of volume. The usual units of concentrations are moles per liter, and in chemistry we write liters as dm3. So moles per liter is moles divided by dm3. This is often written as moles dm to the minus 3. So that equation again, moles is concentration times by volume, which gives concentration in moles per liter by dividing moles by volume. So let's go through an example to really set that knowledge into place. If we have 3 moles of NaCl and they're dissolved in half a liter of water, what is our concentration? So if we think back to that cute little equation I just went over, concentration is number of moles divided by volume. So we do 3 moles divided by 0.5 dm3. Remember, 1 dm3 is the same as a liter. So our concentration is 3 divided by 0.5, which is 6 moles dm to the minus 3. Easy peasy, right? You guys are feeling good and confident. I hope you are. You've got this. So again, that equation for concentration is moles divided by volume. Okay, so you thought we were done? We got some more to give. Remember, moles allow us to convert between grams and AMU, and we can put this into a nice little equation. So to calculate the number of moles present in a sample, if we know its mass, we also need to know its molecular mass or atomic mass if it's just one atom. And the amount of moles is equal to mass divided by the mR. That's mass divided by the mR. So let's take an example of benzene, which might have featured before in a previous episode. Ooh, maybe you should check them out. If benzene has a relative molecular mass of 78, remember, mR is the same as relative molecular mass. How many moles of benzene are there in a 7.8 gram sample of pure benzene? So that equation again, moles equals mass divided by mR. Our mass, we've got 7.8 grams. mR, that's 78. So 7.8 divided by 78 is 0.1 moles. Okay, so I feel like maybe we should go through a little example. So let's talk about maleic acid. Let's say we've got 29 grams of maleic acid and we dissolve that in 0.25 dm3 of water. Now, maleic acid, if you don't know what it is, don't you worry about it. I've got its formula coming right up. It's C4H4O4. It's a diprotic acid. That means it's got not 1, but 2 protons. So we want to calculate the concentration of protons in the solution. Ooh, this is a nice little synoptic question, getting some acid knowledge in there too. So first things first, we always calculate the molecular mass. So remember that formula was C4H4O4. So use a cute little periodic table. Carbon has an atomic mass of 12. hydrogen of 1, and oxygen of 16. So we'll do 4 times 12 for the C4, 4 times 1 for the H4, and you guessed it, 4 times 16 for the O4. We add that all together, that gives us a nice MR of 116. Now let's calculate the number of moles. Do you remember that equation for calculating moles? It is mass divided by MR. We had 29 grams, so we divide that by 1.16, and that gives us a nice little 0.25 mole. Now, if we think back to that question, we wanted the concentration of protons in the solution. So first of all, let's calculate the concentration of maleic acid. We know we have 0.25 dm3 of it. So to get the concentration, we do the number of moles divided by the volume. So 0.25 mole from step 1 of our calculation, divided by 0.25 dm3, that's the volume of liquid we have, gives us 1 mole dm3. Are we done? No, we're not, because we want the concentration of protons in the solution. And maleic acid is diprotic, not 1, but 2 protons. This means we get 2 protons per molecule in solution, so we just need to double that concentration to give us a nice little 2 mole dm to the minus 3. Bam! Okay? So let's change things up a bit, and I'm going to tell you that a mole of liquid weighs 18 grams and has a volume of 36 centimeters cubed. What's the density of the liquid? Do you know how we do that? Well, all we do is we take the grams and we divide that by the volume. So it's just 18 divided by 36, which gives us 0.5 grams per cm cubed. Okay, we've covered a lot. Let's consolidate and go over some key facts. What is true of moles? Is it a number or is it a unit of mass? Honey, it's just a number. Don't panic. It's just a number. And it contains Avogadro's constant of things, so 6.02 times 10 to the 23 molecules. And a mole is the number of atoms which have the same mass in grams as one atom does in AMU. Chill, right? Okay, to finish off, let's go through one more example. What is the concentration of Br- if 1 mole of MgBr2 is dissolved in 1 liter of water? Now, thinking about what we need to calculate, do we need to calculate the MR of MgBr2? No, we don't. This is just a nice little concentration volume question because we already have the amount of moles. We know we have 1 mole of MgBr2. Now, looking at that formula and looking at stoichiometry, that's just a posh way of saying ratios. We can see that MgBr2 has 2 bromine atoms, so 1 mole of MgBr2 contains 2 moles of Br-. So we have 2 moles, and that concentration again, we have 1 liter of water, so 2 moles divided by 1 liter, 2 moles dm to the minus 3. It's not so bad, is it? So I hope this was useful. I hope you are feeling confident about moles. Maybe have a go at doing some more calculations, go through the unit on the website. It's really helpful. And good luck with all of your A-level revision.